Year 11. Right, we're going to go through now how to interpret velocity time graphs, and in particular how to use one of the equations. The question we've got here is a little bit out of shot, but it's going to ask us to calculate the acceleration between k and O here. And if we look at the graph, we can read a couple of numbers off this. We can take the time, we can take the velocity from this graph, and there's a number of equations that have acceleration within them, but there's only one that has velocity, time and acceleration, and so the one you should be picking off is this one, which acceleration is the final speed, v, minus the starting or initial speed, u, all divided by the time in which that change in speed took place. So interpreting the graph now, our final speed is, if we read across here carefully, those of you that aren't great with graphs, we've got 5 meters per second broken up into 10 squares, which means every 2 is going to be 1 meter per second. So we've got 10, 11, 12, 13. And our starting velocity is 5. So 13 minus 5. Now the time in which that took place started on 3 seconds and ended at 30 seconds. So the actual time in which that change in speed took place was 27 seconds. Now obviously remember to put your numbers into an equation before you rearrange, not that we have to, but that'll have picked you up a mark at least. Simplifying that down, 13 minus 5 equals 8, and 8 divided by 27 gives us quite a big number, but we always put it to 3 significant figures unless asked otherwise. 0.296. The next number was 2, so we leave this one as 6. And our units for acceleration is meters per second squared. Easy peasy.